Put your phone away. All right, guys, so we are going to be doing 4.6. Hey, we're starting 4.6, but we're not going to finish. We're only going to do tangent and cotangent today, and we'll do secant and cosecant tomorrow, okay? All right, so first off, you do have the graph page, yeah, for your notes? Above the first graph, what I want you to do is just write down y equals tangent of x, okay? Y equals tangent of x. Can you all get your unit circle out? Because it'll be easy if you have yours in front of you as well. I mean, we can look at mine, but I won't always have it in front of me. What is tangent? Sine over cosine? And so as far as these coordinate points go, it's what over what? Y over the x, yeah? So let's go around and figure out what some of these tangent values are. What is tangent at 0?
0.
Yeah, 0 over 1 is 0. What is tangent at pi over 6? Okay, 1 over the square root of 3 or square root of 3 over 3. Either way, it's 0.57 something. I think it's 0.577. Something like that, yeah? What is tangent at pi over 4? 1. What is tangent at this one? Square root of 3, which is greater than square root of 1, right? Which is greater than 1. So as far as y values go, as far as values go, do you see that tangent is increasing? Okay. Until we get to pi over 2, then what's tangent? It doesn't exist. It's undefined, yeah? Okay. So what I want to do is I want to kind of mimic that on the graph. What I want you to label this as, at the bottom of the graph, I don't care if you want to label it within. I'm just going to label it right here. I'm going to let that be a half pi, pi, 3/2 pi, and 2 pi. And let's actually go to the left a half pi as well. Okay, so we're going to plot some of those points. What did we say it was at 0? At 0, it's 0. So at 0, I'm going to plot that point. What did we say it was at pi over 4? Which is just half of that, right? What did we say it was at pi over 4? At pi over 4? 1, yeah. Sorry. At the other ones, it was 0.57, like I said, and then square root of 3, which is up in here. So it was increasing, right? Now, how far does it increase? Well, okay, here's the thing. Do we have a stopping point when we say it goes up to undefined? We don't, because here's why. So, and you don't have to write this down. I'm just going to sketch for a second and show you something. This is sine, yeah? And here's pi over 2. Here is cosine. Cosine starts at the amplitude, right? And at pi over 2, it should be at the origin, yeah? So we'll pretend like I'll fix it over there. Okay, so as we get closer to pi over 2, what is sine approaching? 1. What is cosine approaching? 0. So I have a number that's getting closer and closer and closer to at most 1. Yeah, are you cool with that? Closer and closer and closer to 1. What is the denominator getting closer to? I just misspelled closer. Closer is 2. Closer to 0. Are y'all cool with that? Okay, so if we picked a number that's really close to 1, 0.9999999, that's really kind of hard for me to think about in terms of like dividing it by something. So I might as well just think of it as, I'm going to go ahead and think of it as 1, okay? 0.99999. But I'm dividing it by something that's really close to 1, or 0, and let's pretend like it's 1, 1, whatever, how many zeros that is, right? Whatever. Really close to 1, really close to 0. But what happens when I divide by that? Good. I multiply by the reciprocal, and what does this expression become? It becomes big. How big? Infinity big, yeah? Which means what's happening, guys, at pi over 2? Thank you. It is a vertical asymptote. Well, there's a vertical asymptote on the right-hand side, right here. Let's go left for a second, yeah? Okay, so on your unit circle, what is, this is 7 pi over 4, but it's the same thing as saying negative pi over 4, yeah? What is tangent of negative pi over 4? Negative 1. So at negative pi over 4, we're at negative 1. Yeah, with me on that? Where do you think it's going over here at negative pi over 2? So this again is going to be undefined, and it will be negative infinity, and if you look over here, here's why. This one is again, cosine is still approaching 0, but this is getting closer and closer to what? To negative 1. So this would be negative 1 divided by a really large number, which is negative big. Yeah, negative big. That is a technical term, ladies and gentlemen. Okay, so we have another vertical asymptote at negative pi over 2. And my wave is going to look like this. Almost. You don't have to worry. You don't need to try and have that little cubic wave at the x-axis, though. You know what I mean? So don't try and flatten out to have a slope of 0 because it doesn't do that. Yeah, just kind of slides through it. Hey, okay. Can you tell? Okay, so we left off at pi over 2 on the right-hand side, yeah? Okay, can we go back to the unit circle and look at 3 pi over 4? What's tangent of 3 pi over 4? Negative 1. So at 3 pi over 4, which is halfway between half pi and pi, we're back at negative 1. What are we at pi? Sine over cosine, so we're back to 0. What's it going to do, guys? It's just repeating itself. So let's go ahead and continue that. So we have another vertical asymptote where? At 3/2 pi or 3 pi over 2. We continue the wave, draw it again. Now, guys, do you notice? What? Yeah. Do you notice how I'm getting close to the vertical asymptote on these? You're not always guaranteed to be able to do that, okay? Guys, when you're sketching these, sometimes it might look like you've got vertical asymptote, but your point's down here and your point's up there and right there. Please don't try and like unnaturally be like, okay, and then I'll go back over, you know? No, you don't have to do that. You can just kind of naturally go towards it, and lean away. You know what I mean? So these don't have to be, they don't have to hug the vertical asymptote. Okay, they will eventually. All right, now if I wanted you to graph all the way to 2 pi, how much more of a wave would you see? You would only see half of it. You would see these 2 points, and then there you go. So how many waves, how many tangent waves did we draw? We drew 2.5, yeah? So can you tell me what the period of tangent is? Period is the length of the wave, right? How long did this take? Pi. If you add half pi to itself, right, you get pi. So the formula for the period of a tangent wave, so period in general, is pi over b, no longer 2 pi over b, because we're horizontally stretching and compressing the original parent function's period, which is just pi. Okay? Let me take this out a little bit. All right, what is the period of this function? We just said it. No, just in general. That's the formula. What's this period? Pi. Okay. So the period for this is pi. Can you tell me what the domain is? Okay, before we tell domain, let's go ahead and jump to vertical asymptote. So I don't really care what order you write these in, so if you just want to write down vertical asymptote, where are the vertical asymptotes occurring? Yeah, the first one occurred at half pi, right? And then what was the distance between that one and every other one? Pi. So the vertical asymptotes occur at pi over 2 plus every multiple of pi after that. So plus n pi, where n is an integer. Okay. So the first one is at pi over 2, and every other one is just a pi away from it. Pi away from the previous one to the next one. Okay? All right, so now can you tell me what the domain is? It's all real numbers, except when we have a vertical asymptote. Because those are infinite discontinuities, yeah? Do you remember that?
Yes.
What were the types of discontinuities you could have?
Jump.
Yeah. And is that removable or non-removable? Sorry, Jason said jump. So jump discontinuity is a non-removable. An infinite discontinuity, which is vertical asymptote, is non-removable. What's removable? Just a hole in the graph, right? Because you could plug that. Okay. All right. What's the range, guys? How high up and how low does this function go? So all real numbers. Okay. X-intercepts. Where are the x-intercepts? I see one at 0, and the next one at pi, the next one at 2 pi. So the x-intercepts occur at x equals what? Okay. But isn't pi itself just a number times pi?
You're using the ladybug.
Yeah, because so many people are gone. So how about just n pi? Now remember, I always say start with the first one, so you could say 0 plus n pi, but might as well just say n pi then. Where n is what? An integer. We don't have to write down every time. What's the y-intercept? Okay. Extrema. Do we have any maxes or mins? And there we go. Yeah? So when someone, when you have to remember like graphing a sine wave, you think, oh, starts at the origin, goes up, comes back down, period 2 pi, yeah? When you think cosine, think starts at the max, goes down, comes back up, max again at the end of the wave 2 pi. When I think tangent, I just remind myself, okay, I've got, it splits itself in half across the y-axis. So whatever the period is, this is just half of it. You go with me on that? And then I just remember, hey, it does that. Okay? So it's just a way to remember what the tangent wave looks like. Okay, so let's graph a specific tangent wave. Everyone write down above the second graph, y equals -2 tangent of 2x. And we're gonna graph this from negative pi to pi. Sorry, -2 tangent of 2x. All right. All right. So what do you know? Starts at 0. Okay. Are you talking about because the tangent just like when I think about this starting, it's at the vertical asymptote, but you're talking about in the center?
Yeah.
Okay. Yeah, that's fine. Can you tell me what this is going to determine? The period. Let's go ahead and determine that. Now, hey guys, right quick. You know how on sines and cosines, whenever we sketch them with like doing a dotted line, a dotted curve, and then we move it. It's going to be kind of ugly if you do vertical asymptotes for your original function and for your phase shift. So whenever when we have phase shifts, we'll probably just sketch it out to the side, okay? And then phase shift it and then put it on our function, okay? Unless you're cool with just going ahead and go straight to it. In this case, do we have a phase shift? No, I don't have to worry about that. So anyway, period is the formula what? Pi over b. What's b? 2. So my period is half pi. Okay. So you have a choice. I know I need to graph from negative pi to pi, and I know that my period is half pi. So if my period is half pi, how far to the left and to the right of the y-axis do we go to get to my vertical asymptotes? Remember, I said the tangent, whatever you get, this is just what? Half your period. So what's half of a half? A fourth. So it'd be really nice if this first tick mark was a fourth pi. Does that make sense? Now, do I have enough room for that to be a fourth pi to be able to see all the way to pi?
Yes.
Yes. So I'm going to label this as 1/4 pi, which makes this 1/2, which makes this 3/4, and then makes that pi. So we're going to graph from negative pi to pi. So negative 1/4, negative 1/2. You don't have to label all these over here. I'm just, since I'm here. Yeah?
Yeah, you should edit that out.
What?
You should edit that out.
Edit what out?
Me saying
Oh, you can't hear you. They can barely hear me right now because I'm so far away from it. Hey, that probably just confused them. So, now what do I do? Can we graph our vertical asymptotes? Where are they? Remember, it's half the period, and you just go to the left and to the right, half on each side of the y-axis, and you're good. So where are my other vertical asymptotes? 3 pi over 4? And negative 3 pi over 4? Okay. Can you tell me what the negative means to you? Yeah, so normally tangent does this, but because of the negative, it's going to do what? It's going to come from above and go down. Yeah? Okay, cool. Can you tell me what this 2 does? Ah. Okay, so Belinda's saying, okay, are y'all go, Liam's point was that we start here, right? Y'all cool with that? So now normally, on a normal tangent wave, I would go to the right, only a half of that, and I would go up 1. But since we're flipped, we're going to go up on the left. And then Belinda was saying, because it's a vertical stretch by a factor of 2, you don't go up to 1, you go up to 2. And that's exactly right. So halfway through this, what is this at, by the way, guys? What x value? What is this x value right here? 1/8. Good. And so we're going to repeat that here. And we're going to do half of it here. And we've got it repeated here. And we've got only half of it there. So because the period is smaller, you're bound to see more waves if unless I just ask you. Now on your homework, I'm asking you to graph for the first 4 problems. There's only 6. And only 3 of those are the tangent cotangent, so you only have to do 3 right now. I'm just asking you to graph 2 periods, so I don't really care how you do that. But anyway, you'll see, as you do them. Oop, just kidding, that was kind of bad. I keep shaking the camera. So it's really kind of hard to get a curve in on this one, so just kind of go over towards it. Hey guys, can you talk to me about, ooh, and we're back. Can you guys talk to me about the, I don't even know what I'm saying right now, the relationship between tangent and cotangent? They're just reciprocals of each other, right? Let's go back to this right quick. If I look at this, guys, back on the unit circle, where tangent is 0, what would cotangent be? Undefined. So wherever this one is 0, cotangent has a what? A vertical asymptote. But where, or would you agree that they have the same values at 1, at pi over 4, 3? So all of these values are going to be the exact same. It's just that here they would be undefined, and here they would be what? 0. So if you think about that, so imagine that this is a vertical asymptote, yeah? That's now a vertical asymptote. This is now, let me not make that sideways. This is the point, this is a 0, this is a point, and now this is a vertical asymptote. So what does it do? It comes from above and goes down. Yeah? All right, so write down on the third graph, cotangent. How many waves did we have on this one, by the way? On that graph up there? 4 complete waves, good. All right, so cotangent. Cotangent is what over what? Cosine over sine, x over y. So again, cosine at 0 is what? Because you got cosine over sine, so that would be undefined at 0, which we know means 0 half pi. We're just going to go 0 to 2 pi on this one. Make it a little bit easier. Or faster, anyway. All right. We said that cotangent of 0 is 1 over 0, which is undefined, so we have a vertical asymptote. Okay. What is cotangent at pi over 4? 1. So at pi over 4, we're at 1. What is cotangent at pi over 2? Cosine over sine? 0. So at pi over 2, cosine is 0. What about at 3 pi over 4? What's cotangent? Negative 1. So at 3 pi over 4, we're at negative 1. And what is cotangent at pi? Undefined again, which means we have another vertical asymptote. So we have another vertical asymptote. What's the width of that wave, guys? Pi again. So what's the period of cotangent? Pi, yeah? So if we graphed it all the way to 2 pi, then we would just have another vertical asymptote. We would have these points right here. 1, 0, negative 1. Just come from up here, go down. Yeah? All right, can you tell me what the period is? Pi. Where is the vertical asymptote? Or the vertical asymptotes? Yeah, every pi, right? So just x equals n pi. Okay, what about the domain? All real numbers. Good, except when x equals n pi. What about my range? Goes all the way up and all the way down? Okay, what about my x-intercepts? I just forgot how to spell intercepts. I wasn't even thinking. Okay. I never even write all of that. I know, and that's what I always write, but I just started writing it, and then it was just terrible. I broke. Okay, x-intercepts, when do they occur? Isn't that just the opposite of the last problem we did? Tangent, I mean. Okay, what did I just do? Right, it is an element of, I just wrote the integers. Okay, what about the y-intercept? Okay, what about the extrema? There isn't any. Okay. Just to make us think about it. We will have extrema with secant and cosecant. Okay. All right. So we got cotangent. Now, okay, so you know how I said tangent? You basically just graph it and you split it half on either side of the y-axis. Well, for cotangent, what I just always remember is cotangent has a vertical asymptote, comes down, and then whatever the period is, that's the first vertical asymptote. Okay? Yeah? All right, we got one more to graph today. So I need you to write down that function above the last graph on the front. Now, if you're taking notes at home, then you probably don't have that notes page, although I will send it to you. So unless you can print it, you don't have it. You might want to pause the video so that you have time to draw your graphs once you see what the window is going to be. So in fact, I gave you this window, which goes 6 tick marks to each side, and then 5 up, 5 down. Okay, but anyway. All right. And please press the like button and subscribe. I hate that. Oh my gosh. Oh, like fast forward 10 seconds. Okay. Not that I spend time on YouTube. I'm a productive adult. Okay. So what do I do, guys? Also, cute heart. They are really cute.
What?
My heart.
Oh, yeah.
And back to the problem. Hey, what does this +1 mean? That center line, right? So those are where the x-intercepts are going to occur. Okay, so let's draw a horizontal line through 1. Guys, do we have an amplitude in these tangent cotangent waves? We do not. So we don't have an amplitude line. We just have to remember that what does that vertical stretch change? Those quarter points, right? Yeah. Okay. All right, here we go. What is the period? The formula is pi over b, and what's b in this case? 1/2. So that becomes 2 pi. And now this is cotangent. If it was tangent, then I would split it. I would go left pi and right pi, yeah? But since it's cotangent, I just start at 0 and I go to 2 pi, right? But remember, we have a phase shift on this one, yeah? So I'm going to actually, let me write that down again. 3 cotangent of x over 2 plus pi over 4 plus 1. Okay. I'm going to draw a little x and a y down here. We're just going to kind of play around with it. Okay. I know that the period is 2 pi. Cotangent has a vertical asymptote. This is the one, remember this is the one that we're going to draw without the phase shift, yeah? So I'm going to go ahead and draw a vertical asymptote at 0, and I'm going to draw another vertical asymptote, and I'm going to label that 2 pi. So I guess my question for you is, how many tick marks do you want between 0 and 2 pi? Do you want 2 tick marks or whoosh, ah. Do you want to go 4 tick marks to get to 2 pi or 2? 4 is nice because it gives you a little bit more space, and we'll be able to fit that on there, right? Okay, so let's on our paper halfway, yeah. So label that on your little picture down here. Okay. What does cotangent normally look like? Starts from above and comes down. So halfway through it should be at the midline. And then it should be up here. How far up should it be? 1, 2, 3 points up. And then it should be 3 points down. So 1, 2, 3. Yeah? So my in general wave is going to be like this. Now do you see how like the steeper your stretch is, the harder it is to draw your wave as a wave? It just kind of like looks linear almost. Y'all with me on that? Okay, so the only other thing we need to figure out is what? I guess I could have zoomed in on this. And focus. Are we gonna focus? Okay, we are. We need to figure out the what, guys. Thank you for saying that so slowly. Okay, so the phase shift. What is the phase shift? How do I determine that? Negative C, or yes, you could do that. Negative C over B. So negative pi over 4 divided by 1/2, same thing as multiplying by 2. So what is that? Negative half pi. Okay, so we know that when we graph this, if we go from 0 to 2 pi, what is each tick mark a width of? If that's 2 pi and that's pi, then that makes this half pi. So how much is half pi? 1 tick mark, right? So let's go ahead and start labeling. I know that I want to go over here to 2 pi. This is pi over 2. This is pi. This is 3 pi over 2. This is negative pi over 2. Yeah? So where is this vertical asymptote now, guys? To the left, pi over 2. So my first vertical asymptote should actually be at negative pi over 2, because we went to the left pi over 2. Where is this second vertical asymptote? At 3/2 pi. Good. Okay. Where is the point in the middle? It's at x equals what? Half pi, and that would be at the y value 1. Where is the point at 0? Up at what? 3 up from the midline, so up at 4. And then where is the one at pi? Negative 2. All right, so we connect them. It's kind of a big, yeah. It's kind of ugly, but whatever. I don't like that at all. I know, but I don't like graphing it this wide on here. I wish my graph is really large. And yes, I did make a phone. Thank you. Just for you. Okay. And by you, I mean all of you. Okay. Hey, did we follow the directions? Is this graph what? So that's up to you. Do you want to graph another one over here? Or do you want to graph like half over here and half over there? I don't really care. Well, I'm going to graph half on the other side. I don't really care what you do. I just make sure you graph 2 periods, okay? So I could just go another 4 tick marks and put another vertical asymptote, or I could be rebellious because I don't want to have to draw another vertical asymptote. And just do another half up here, and another half down here. Okay, cool. Now, now I'm going to graph this on the calculator. I'm going to see if we're good. Okay. And if we're not, we're just going to throw it away. I'm going to graph 3. How do you graph cotangent, guys? Thank you. 1 divided by, oh my. That's bad. How about 31 divided by 31? Jennifer. 3 divided by tangent of, oh my gosh, yes. Sorry, I'm like, my brain. Okay, x divided by 2 plus pi divided by 4. Plus 1. What window do we want to graph it on? Wow, I got. We're in radian mode. I just grabbed a calculator. No other class have I graphed it for them with them, so maybe I'm just trying to make you guys feel a little bit more special, or I'm just trying to prove that we got it right. All right, guys, what window should I graph it on? What window did we look at it on? How about negative 2 pi to 2 pi, or negative? How about negative 3 pi to 3 pi?
Yes.
Negative 3 pi to 3 pi. How much should each tick mark be? Not 90. How about half pi? Because that's what we have our tick marks as, right? Y values? I think I have negative 5 to 5 on there, so I'll just go ahead and go negative 5 to 5 so it's consistent. And there we go. Now, guys, do you see how I'm going towards the vertical asymptote? In actuality, what it looks like is the graph is a little bit more like up like this, and then it comes down like this, and it would take a long time for it to get there. Because where's the vertical asymptote? Where's this vertical asymptote? 3 has? So 1, 2, 3. So this vertical asymptote should be here. Yeah? Oh, you can't even see that. 1, 2, 3 here, and right here, right? And so there we go. Yeah. Yeah? Okay. Wasn't that fun? Let's do this again like tomorrow.